Okay, all of you, have a look at this question. There's a function f, and domain is 0 to infinity, and range is also 0 to infinity. So there's a function f, domain 0 to infinity, range 0 to infinity, and fx is x by 1 plus x. So the question is, you have to identify the function. Okay, what is f? Is it 1 to 1 but not on to? It is on to but not 1 to 1. It is 1 to 1 on to. It is neither 1 to 1 nor on to. Right? So this is the function, and you have to identify that the function is belonging to which of these four categories. That is a question. Okay, now in the previous session, I have already told you that there are four types of functions: 1 to 1, onto, 1 to 1 into, many to 1 onto, many to 1 into. That I have already told you in the previous session. Now, in today's session, what we are going to do is we are going to investigate two legitimate methods, two proper methods to find out whether a function is 1 to 1 onto or not. And both the methods are equally good, but in your school exam and board exam, only the first method is recommended. The second method is actually a direct method. You have to get the answer by drawing a graph, but that is not recommended in your school exam and board exam. As a knowledge, you can keep it in mind, and it will be helpful for competitive exam. But for school and board exam, the first method is only the better method. So what is that first method? So the first method is that whenever you have to find out whether it is 1 to 1 or not, you start by saying that suppose f of x1 and f of x2 both are equal. So suppose f of x1 and f of x2 are equal. So x1 by 1 plus x1 is x2 by 1 plus x2. So then you cross multiply. So you will get x1 equal to x2. Okay, so f of x1 equal to f of x2. So that means x1 by 1 plus x1 is x2 by 1 plus x2. So x1 into 1 plus x2 is x2 into 1 plus x1. So if you cancel, you will get x1 equal to x2. So by taking fx1 equal to fx2, we got x1 equal to x2. This clearly shows that the function has to be 1 to 1. There is no other option. Means whenever fx1 and fx2 are equal, automatically x1, x2 are equal. That means it is 1 to 1. Okay, now for checking it is on to. For checking that it is on to, you take y equal to x by 1 plus x, then you cross multiply. So y is equal to x by 1 plus x. So y into 1 plus x is x. So x into 1 minus y is y. So x is y by 1 minus y. Okay. So y is equal to x by 1 plus x. If you cross multiply, y into 1 plus x is x. So x into 1 minus y is y. So x is y by 1 minus y. Right. Now, now the problem is that y cannot be equal to 1. If you look at this carefully, x equal to y by 1 minus y, if you look carefully, you will realize that y cannot be 1. Because if y is 1, y cannot be 1, because if y is 1, then what will happen? The denominator will become 0. So if you look at this expression carefully, you will realize that y cannot be 1. but the domain is 0 to infinity and range is also 0 to, codomain is 0 to infinity. But y cannot be 1. So in the codomain 0 to infinity, the value y equal to 1 is not acceptable. So that means that codomain is not equal to range, right? So that means it is not onto. Okay, so codomain is not equal to range, so that means it is not onto. So this is how you have to remember. x1 equal to x2 means it is 1 to 1, and codomain not equal to range means it is not onto. So that means it is 1 to 1 but not onto. So this is the orthodox conventional method which is recommended in your school. So for 1 to 1, you start with fx1 equal to fx2. And after solving, if you only get x1 equal to x2 and if you don't get any other answer, that means that it is 1 to 1. So I only got x1 equal to x2, I didn't get any other answer, so it is 1 to 1. And by expressing x in terms of y, if you realize that codomain and range are unequal, then it is not onto. So by putting x in terms of y, you did found that codomain not equal to range, so that means it is not onto. So finally it is 1 to 1 but not onto. What is the other method? I told you there's another method. So what is that other method? The other method is so the other method is that you graph this function x by 1 plus x, you graph it. See, drawing a graph is actually not a bad method. In fact, if you ask me, it's actually, if you see, I have just drawn the graph and I'm going to tell you the answer by just looking at the graph. I'll tell you how. But whereas this one was, all this writing work, but your school and board does not recommend graph. That is a problem. You will not be penalized, I guess, but it's not a recommended method. Now, how did I draw the graph? So there's this concept called asymptote. Normally when you are asked to draw a graph, by instinct the first thing you do is you put x equal to 0, see how much is y. You put y equal to 0, so see how much is x. Now if you put y equal to 0, then like if you put y equal to 0, then x is 0, so it's passing through the origin. Okay, now there is a thing called asymptote. If you put x tends to infinity, then you will find that y tends to 1, right? If x tends to infinity, then y tends to 1, right? And if x tends to minus infinity also, y tends to 1. And when x is higher than minus 1, right? So, okay, actually there is a slight mistake in this graph, sorry all of you, a slight mistake in the graph. No, it's okay, there's no mistake, it's alright. Okay. It's alright. There's no mistake, it's alright. This is the graph. So when x is slightly more than minus 1, it will start from minus infinity. Like I said, it will cross at origin, and when x tends to infinity, it will become 1. When x is slightly less than minus 1, then it will start from positive infinity, and when x is minus infinity, it will again become 1. So the graph has two branches, non-intersecting two branches, It's pretty clear from the graph that it is 1 to 1. You can see that for any value of x, you are getting only one value of y. And it's pretty clear that y cannot ever be equal to 1. That is the concept of asymptote. So there are two asymptotes, x equal to minus 1, y equal to 1. So x can never be minus 1. And by the way, we are supposed to have 0 to infinity, 0 to infinity, right? So I guess there is no need to draw so much. Actually the domain is 0 to infinity. So after I have drawn the graph, I can just leave out this portion, because you know the domain is 0 to infinity, so there is no need to draw this portion. So this is how the graph will be, right? So it is 1 to 1, okay, but y can never be equal to 1, and since y cannot be equal to 1, so it's pretty clear that the function is not onto. So it is 1 to 1 but not onto. So these are the two methods to prove whether a function is 1 to 1 or onto. One is the actual method, the rigid method. The other is you just draw a graph, and from the graph you comment whether it is 1 to 1 or not, whether it is onto or not. So this is the topic. So I'll give you the homework questions as usual. Okay, the first homework question. There is a function which maps real number to real number. Fx is 2x plus sin x, and x belongs to real number. So f is 1 to 1 onto, f is 1 to 1 but not onto, it is onto but not 1 to 1, and it is neither. So this is the first question of your homework. Second question. Okay, the next question is, so these are the 4 homework questions for today. The first question is f maps real number to real number, fx is 2x plus sin x, and x is a real number. So function is 1 to 1 onto, 1 to 1 but not onto but not 1 to 1 neither. Question number 2, there is a function which maps real number to real number, fx is x minus n by x minus n, m and n are not equal. So options are 1 to 1 onto, 1 to 1 into, many to 1 onto, and many to 1 into. Then question number 3, function maps natural number to integer. So fn is n minus 1 by 2 when n is odd, and fn is minus n by 2 when n is even. So it is 1 to 1 but not onto but not 1 to 1, 1 to 1 onto, and neither. Number 4, function maps real number to real number. fx is greatest integer x, so it is only 1 to 1, only onto, both, and neither. So these are the 4 homework questions, and there is no session tomorrow. So this homework you have to finish it by 9 p.m. of Monday and submit it anytime by 9 p.m. of Monday. So that will be all for today, and on that note I'll end this session. Thank you. Bye all of you.